Hi everyone, in this video series we will cover the entire Solodit vulnerability checklist and provide real-world examples for each so you can understand more easily. So let's check out the last access control vulnerability. Does the contract use tx.origin in validation? Use of tx.origin for authorization may be abused by a malicious contract forwarding calls from the legitimate user. Use message.sender instead. Require tx.origin equal to message.sender is a useful check to ensure that the message.sender is an EOA account. First, let me show you the difference between message.sender and tx.origin. Assume that is a contract, and here is an EOA account. And this EOA account interact with this contract when he call a function inside this contract. In this transaction, tx.origin will equal to message.sender. And let's see the second scenario. Assume that here is two contracts, contract 1 and 2. And again, here is another EOA account, and this EOA account called function, let's say the f1, and this f1 function external calls this f2 function, and in this transaction tx.origin equal to message.sender. But when this f1 function external calls this f2 function, the tx.origin will be EOA account, which dot standard is equal to this. Let me call this C1. This contract 1 and contract 2. The message.sender will be contract 1's address. And here tx.origin not equal to EOA account, and this may create attack scenarios like phishing attacks. We will see an example here. There is a finding from Trailers of Bits, use of tx.origin for access controls. The wallet factory uses tx.origin to authenticate users. This pattern is commonly considered insecure, and it could result in the creation of undesired wallets or wallets in a vulnerable state. Here is the function, and this function uses tx.origin when it creates a wallet. Let's see the exploit scenario here. Bob frequently creates nested wallets that hold USDC tokens. Eve notices this and tricks Bob into transferring a token with a callback, and she uses the callback to create and call tx origin, this function. And during the wallet's initiation, the wallet approves Eve to transfer all of its USDC tokens. The new wallet is shown in the nested finance interface. Bob starts using the wallet, After some time, the vault holds 10 million worth of USDC. Eve steals the tokens. And we should never use tx.origin for authentication. Here is the simpler way to explain this vulnerability. I took this from Solodit by example. I will show you how this attack scenario works step by step. Here is a vault contract. The owner of the contract, when deployed this, he sends it here, and whenever he wants, he calls this transfer function and sends this address with this amount. And here is a check here, the tx.origin should equal to the owner. And here is the attacks contract that has attack function. It will deploy with this wallet address, and let me show you how it goes. The first address will be Alice, and this second one will be Eve. And Alice is deployed with 10 ETH, this vault contract here, and then Eve deploys attack contract with address of Alice vault contract. And so I will take this, and Eve is deploy. Okay. And then Eve tricks Alice to call this attack function. Here, this function is called this transfer function, and this transfer function checks the tx.origin. And here is a phishing attack, obviously. Here is how it works. This EOA account will be Alice, and Alice calls attack function. This is the attack contract. Let me draw it. In this case, when Alice calls this attack function will call this, and tx.origin here will be Alice's address. So this is not working properly, and this attack function will send all the money to owner of this attack contract. In this case, it's Eve. And Eve tricks Alice to call attack. Alice call this attack. Okay. And Eve successfully stole Ether from Alice's vault. Here, as we can see, Eve has 110 Ether here. And if you want to see different attack scenario that comes from tx.origin, you can check here. There is a CTF solution. And thanks for watching.